So let's take a look at dividing now. So let f of x equal to x plus 2 and g of x equal to x squared plus 9x plus 14. So determine the equation of the function h of x is equal to f over g of x. Okay, so let's do that first then. H of x is equal to, so our f of x is x plus 2, and our denominator is x squared plus 9x plus 14. Now this looks really similar to unit 9. So now we have a function that has polynomials on the bottom and the top of this fraction. Now we should simplify it as much as we can. So I'm going to factor the denominator. Maybe I'll get lucky. Maybe there's something that I can cancel out. Oh yeah, x plus 2. So we get x plus 2 times x plus 7. So we're really left with 1 over x plus 7. Okay, so we kind of know what to expect with this graph then. We should have just the regular reciprocated function that's shifted over left 7. So B, sketch the graph of f of x, g of x, and h of x on the same set of coordinate axes. State the domain and range of h of x. Okay, well, let's do the easiest one. F of x is equal to x plus 2. So that means my y-intercept is going to be 2. And then I've got a slope of 1. So we're going to keep on going up by 1 here. I'm not going to draw the lines here. I want to make this as accurate as we can. For this one at least. Okay, so that's my f of x. Now for g of x, because I've already factored it, I'm going to just do it a little bit differently. So we have x plus 2 and x plus 7. So then I know that I have intercepts at 2 and 7, or negative 2 and negative 7. So negative 2, negative 7. And just based on symmetry then, so if I go negative 2 plus negative 7, I get negative 9. And then I can half that, so I get negative 4.5, which means my vertex is at negative 4.5. And then I'll just go and substitute negative 4.5 into g of x and figure out what that height is at that point. So negative 4.5 plus 2, and then negative 4.5 plus 7, and you get negative 6.25. So therefore I have this point negative 4.5, negative 6.25. That's going to be my vertex. So negative 6.25 is around here. Okay, so now I can start kind of just sketch my graph. Now this is quite steep. I know that because I have a y-intercept of 14, which is way off the graph. Maybe not quite that steep, but it's not going to matter too much more for our purposes. And finally, h of x. Now there's two ways to do this. I could, just like I said, this is just going to be shifted to the left over 7, which means my vertical asymptote is going to be at negative 7. Now what's really interesting about this, and kind of the purpose of why we're doing this, is if I look, I'm going f of x divided by g of x. So it's red divided by blue. Well, here we'd be dividing by 0. So that's why we get an asymptote. And you know what? Here we'd be dividing by 0 again, except for that's going to be canceled out of that. So we don't have to worry about that one. Okay, and then now we do have an asymptote at y is equal to 0 as well. Don't have to write that one in. But there is no stretching on this. It's just shifted over 7 to the left. So then this would be my positive portion of this. And we've drawn this a lot of times in the last chapter, so I'm hoping you remember how we're getting that. And then the negative one, so this would be where negative 1 comma negative 1 is, shifted over 7. And then the rest of our graph will look something like that. And so that's going to be our h of x. But the part that I really want to look at is, yeah, when you're doing this division, it's actually the red divided by blue, red divided by blue, red divided by blue, red divided by blue, over and over again. And so now we do still have to do the domain and range of h of x. So we'll do that here in the bottom left in green. So our domain, well, it's kind of based on what our other two graphs were, but because it's the division, we can't divide by 0. So we have to actually watch out before we even do this cancellation that we don't forget that one right there. Because there really should be a point of discontinuity then. And we should go and add that to the graph. So for our x values, it's x such that x cannot equal -2 or -7, but otherwise x is a real number. And then for our range, well, our range is everything but 0, so y such that y cannot equal 0, but otherwise it's still a real number. Now as for that point of discontinuity, we'll do that at the top here. So we have to figure out, well, based on this, if x was -2, so we'll do h of -2, that becomes 1 over -2 plus 7, so we get 1 over 5. So at x is equal to -2, so way over here, we didn't even make it that far, it's at 1/5. We can label that point as -2, 1/5.